So, welcome everyone again to this video. I hope you have gone through the theoretical part of hypsometric curves and now you are ready with the concepts and you are ready to learn the QGIS procedure for calculating hypsometric curve. So in QGIS, there are some inbuilt processing tools in the toolbox using which one can calculate hypsometric curves very quickly. So for this, we just require drainage basin boundaries. Okay, now as many as you have, you can plot that directly into QGIS and a DEM which has been filled. Okay, so if you want to learn on how to delineate watershed boundary and how to calculate this filled DEM for your region of interest, you may visit the playlist on this channel. I will provide the link for the same in the description box. The datasets used in this exercise is also provided in the description box through a Google Drive link. So you may download it from there and then practice the creating these curves. And so let's begin our exercise. For this, you have to first load this raster and vector data. Vector is your drainage basins and EM digital elevation model, okay, which is your raster data. And after that, you will go to processing and you will click on the toolbox. Okay, processing and toolbox. So when this toolbox appears on the right hand side of your screen or any part of your screen, then in the search box, you have to find hypsometric curves. Okay, hypsometric curves. Double click here. It's a very simple and very short procedure. And here you have to give your DEM for which you want to analyze the hypsometric curve or the values. For example, values like your area and your elevation values. Okay, so this is going to give us the absolute values. Okay, absolute method of calculating hypsometric curves. So DEM which we want to analyze is our filled DEM. This is also given in the projected coordinate system. Okay, we are not using geographic coordinate system here. And the drainage basin boundary layer. Okay, you have to provide any boundary layer for which you want to calculate these curves. Step you can give at what elevation steps you want to calculate these curves. Okay, you may give 100, you may give 50, whatever you think suits the your objectives. Okay, and here you can use the percentage of area instead of absolute values. Okay, this also you can take the box. Okay, we will see how this is different from the absolute values. Okay, and here you have to save it to the directory, and where you can connect the folder in which you want to save your final results. Okay, you have to select the particular folder and then click on run. Okay, it's complete. Here your the loading result layers algorithm is finished. Close the screen and go back to the folder where you have saved your hypsometric curves. Okay, so this is provided in the form of CSV. Okay, the CSVs are created. Let's open this CSV. Okay, you see here we have elevation and area in meters, meter square and meters. Okay, so here I want to convert this area into kilometer square. For that I will use the Excel method. Okay, MS Excel method of converting the values. Simple. Okay, let's drag it like this. So this will be my area in kilometer square. Okay, and let's also convert our elevation values to kilometers. Divided by 1000. Okay, okay, so we are going to use these two columns to create our curve, create these hypsometric curves. Okay, so what you will do, you will select this, press the control button and select another column for which you want to use the data. Then you will go to insert, and here in charts you will go to this option. Here you will find this line graph, smooth lines, scatter with smooth lines. Okay, so you may drag it to any place which is fine for you. Okay, now you see our curve is created, hypsometric curve is created, and this might look familiar with what you have seen in the first theoretical part. Okay, now let's adjust these values in a way that it looks better. Okay, now it is a lot of extra spaces, so I'm going to adjust these curves. Okay, so first with the this x-axis. Okay, so what is the smallest value here in the x-axis? It is 1536. Okay, so I'll just put this value here to the minimum value. Okay, and what is the maximum value? Here let's go and put the maximum value. Okay, and also we can round it off, let's say up to 1536, so that our x-axis looks better. Okay, and yeah, I think it is fine now. Let's do the same for our y-axis. The smallest value is 0.594, right, and the highest value is 1.494. Okay, so this is how your curve looks like. Okay, this is your hypsometric curve, and which gives us the idea on what is the erosional stage of a particular drainage basin. Okay, so let's finish this by styling a little bit. Okay, I'm going to format this. I'll select here and I'll say it no solid line and no fill. Okay, so I think this looks better, and we have different styling options, so let's go to them one by one. Okay, and here we can put the tick marks, maybe outside or inside, whatever you think is fine. Okay, here also I'll put it inside, and we will put solid line, we'll change the color, and we will also increase the thickness. Okay, 1.75, this looks fine. This again we are going to do it here. Okay, and now about the text. Okay, for text you can select all of them and change it, for example, to Aptos display, and if you want to increase the size, you can use it like that and change the color to black and make it bold. Okay, I want to remove the heading here. I want to put the excess titles. Okay, this is my elevation in kilometers, and this is my area in square kilometer, right? Okay, so this is my hypsometric curve. If you want to change the color, then select the line here and make it red or whatever color looks fine for you. Okay, now this is my hypsometric curve. What about the hypsometric integral value for this particular drainage basin? Okay, so for that we require first the mean value. Okay, so we will calculate the average of elevation, right? If you look into the formula, so that is h mean minus h minimum divided by h maximum minus h minimum, right? So for now we will apply the formula h mean minus h minimum, brackets closed, divided by brackets open, h maximum minus h minimum. Okay, so our hypsometric integral value is 0.5. Okay, and so if we look at the presentation, then you will see that this represents the S shape of the curve, and the value is between 0.35 to 0.6, and this represents the equilibrium or mature stage and where the basin development has attained the steady state. Okay, so this is the final conclusion we can make using this particular hypsometric curve. Okay, so I hope this is clear, and you can perform the similar analysis with your second result. Okay, yeah, this one. Okay, you can perform the same thing with this particular all these values as well. So I hope this calculation of hypsometric curve was clear with all of you how it can be done, right? So in next video we are going to learn a longer method or a different method of calculating hypsometric curve using QGIS.